Hello everyone, I am Romel Carlo Valdivieso and I will discuss to you about definite integrals. When we find the area under the curve by adding rectangles, the answer is called a Riemann sum. The width of a rectangle is called a subinterval. The entire interval is called a partition. Subintervals do not all have to be the same size. If the partition is denoted by P, then the length of the longest subinterval is called the normal of P, and it is denoted by the normal of P. As the norm of P gets smaller, the approximation of the area gets better. So the area is equal to the limit from P to 0 is the summation of x is equal 1 to n f of c of subinterval of k sub prime x sub k if P is a partition of the interval a and b. It is called the definite integral of f over a and b. If we use the subintervals of equal length, then the length of a subinterval is the prime x is equal to b minus a over n. The definite integral is then given by that equation. Leibniz introduced a simpler notation for the definite integral. From this to this. So f of x dx is the integral of f of x dx from a to b. Noted that the very small change in x become dx. So we have the integration symbol, the lower limit of integration, upper limit of integration, the integrand, and the variable of integration. It is called a dummy variable because the answer does not depend on the variable chosen. We have the notation for integration, but we need still to learn how to evaluate the integral. We consider an object moving at a constant rate of 3 feet per second. Since the rate times time is equal to distance, so we have the constant rate of 3 feet per second times time is equal to d. If we draw a graph of velocity, the distance that the object travels is equal to the area under the line. So after 4 seconds, the object has gone 12 feet. So 3 times feet per second times 4 seconds is equal to 12 feet. If the velocity varies, velocity is equal to 1/2 times time plus 1. The distance is s is equal to 1/4 times time squared plus t. C is equal to 0 since s is equal to 0 at t is equal to 0. After 4 seconds, so the distance is equal to 1/4 times the time, which is 16 plus 4. So the distance is equals to 8. So the area is equal to 1/2 times 1 plus t times 4 is equal to 8. The distance is still equal to area under the curve. Notice that the area is a trapezoid.